This is the Modern Einstein with a Science Talk segment, and today we're going to be talking about a method called Kerpa check. It's likely that you have not heard of this or have no clue what I'm talking about, because this was actually developed by the department head of science at the school that I go to, and she developed this, and what it is, as you can see that I wrote, it's a way to organize your work and science mostly. In this example I'm going to be using it in physics. So it's really easy what the method is. So I'll go over that really quick. Each letter stands for something. So the K on Kerpa is what we know or what we want to know. The E is the equation that we'll be using. And we go down. The R is, do we need to reorder the equation? So say we have an equation, but we need to solve for a different variable in that equation. This is where we will reorder it. The P stands for plug in, so we plug in the numbers. And A is answer, and then the check is check. Now the difference between answer and check, as you can see, they're two different things. I kind of put them side by side because they seem the same a lot, but they're different, especially in physics. You should have hopefully you watched my other video on significant digits, okay, and that comes into play a lot in physics. So we give our answer, and then our check is that answer rounded with the correct amount of significant digits. So I gave a really easy example up here, and we'll go over it. Okay, so say we were given a problem and we knew that VI, which stands for our velocity initial, we knew that it was 5.0 meters per second when it started. We also knew when it ended, which is our velocity final, VF, that equaled 10.0 meters per second. We also knew that our delta T, remember delta means the change in, so we knew the change in time equaled 0.5 seconds. So we'd move on down to our E, and our equation would be, if we're wanting to find the acceleration, by the way. So our equation would be, our acceleration equals our velocity final minus our velocity initial divided by the change in time. So we move down to R, and we don't need to reorder because, look, it's already solving for A, which is what we want, which is acceleration. So we move on down to plug in. So we remember our equation is acceleration equals the change in velocity over the change in time. So our velocity final was 10.0 meters per second minus our velocity initial, which was 5.0 meters per second, divided by the change in time, which is 0.5 seconds. That gives us an answer of 10. And then, sorry about that, the significant digits would be the same as the answer given. So our acceleration equals 10, and remember the units on acceleration is always meters per second squared. So our acceleration would be meters per second, or 10 meters per second squared. Now you say, maybe that was fairly easy for you, and you might have been able to do that in your head. Well, this example was just an example. That's what it was. And what this really comes in handy for, what Kerpa check really comes in handy for, is really big equations. Equations that are kind of messy and there's a lot to them. And this is kind of a way to just sort out everything and keep things organized. And it really helps. And I use it almost all the time with all of my equations that I do that are a little bit harder than this. So If you have any questions, like always, the best way to ask a question would be to email us, because we always check our email. If you have any comments, you can comment, and you can also subscribe to the Modern Einstein. So, thanks for watching, guys. See you next time.